Hello student, this is Darasa Online. My name is Edgar Mshana. I'm teaching Advanced Mathematics. Today with the topic of differentiation, and we are going to see the application of differentiation. Where are we applying the method of differentiation? We are saying that is differentiation is used to determine the stationary point. Stationary point. But also the nature of this stationary point, if it is maximum or minimum. Therefore, we say and the nature of the stationary point, if it is maximum or minimum. So my dear student, let us see some review questions in which you are going to see how to determine the stationary point and also to test the nature of this stationary point, if it is maximum or minimum. So here, my dear student, we have a review question. Number 1, we are supposed to find and determine the nature of the stationary point of y is equal to x squared minus 4x plus 5. So the solution for this review question, the first step, we are going to find the first derivative of this equation. That is, just find dy dx, this is equal to 2x minus 4. So that is the first derivative of our equation. But remember, at the turning point, dy dx is equal to 0. So here we say, but at the turning point, we say dy dx is equal to 0. So in this case, we have 2x minus 4 is equal to 0. So in this case, it is possible to find the value of x. That is, 2x is equal to 4. So just divide by 2 by 2. Now we have x is equal to 2. Now we have the value of x. It is time to determine the value of y by substituting the value of x in our equation. So in this case, we have y is equal to x squared minus 4x plus 5. So on substituting the value of x, we have y is equal to 2 squared minus 4 times 2 plus 5. Therefore, y is equal to 4 minus 8 plus 5. So in this case, the value of y will be, that is 9 minus 8, which is equal to 1. So, my dear student, at this point, we have the stationary point. So here we just say the stationary point now. The stationary point, that is 2, 1. So 2, 1, it is our stationary point. So we want to test whether this point is a minimum or maximum point. So we can prepare a simple table that would help us to test whether this stationary point is a maximum or minimum. So we have here the value of x, that is the value of x. And of course, here we have the sign the sine of dy dx. So, my dear student, here we are going to consider two sides, the left-hand side and the right-hand side of the value of x. So, here the value of x is 2. So, we are going to take just a number in the left-hand side of 2, and again the number that are in the right-hand side of 2. Now, suppose in our left-hand side, we just take 1.9. So you substitute 1.9 in dy dx. So on substituting, that is, let x is equal to 1.9, because 1.9 that is in left hand side. So you substitute 1.9 in our derivative. So it will be, in this case we have dy, that is dy dx will be equals to 2 times 1.9, then minus 4. So in this case, we have 3.8 minus 4. In this case, we have negative 0.2. So the value of the dy dx, it is negative. So the sign, of course, here is a negative. Of course, when you substitute 2 in dy dx, here we are going to get 0. Now, what about the value which is in right-hand side? Now, suppose again we take 2.1. So this time suppose x is equal to 2.1. So we substitute in our dy dx. So in this case, dy dx, that is dy dx will be equals to 2.1 and minus 4. So here we have, that is 4.2 minus 4, which is equal to 0.2. So in this case, dy dx is positive. So here that is positive. That is positive. So, my dear student, what does this mean? Because in the left-hand side of 2, we have a negative. But in the right-hand side, we have a positive. What does this mean? This implies that if we just make a rough sketching of the graph, negative, that means the graph is going down. That is the interpretation for a negative. And again, for 0, that means it was somewhere here. That is the stationary point. So again, for the case of positive, it means the graph was going up this way. So the simple interpretation, this is the parabola. And if the parabola is having this nature, we can get the minimum point. So at this point, which is the stationary point, we have the minimum point. So in this case, the stationary point, that is 2,1, is a minimum stationary point. So in this case, you have to make a conclusion. That is, since dy dx is less than 0 on the left, as you can see here, and again dy dx is greater than 0 on the left, as you can see here, that is positive, then we say the stationary point is a minimum. So that is how to determine the stationary point, but again to test it in the nature if it is a maximum point or minimum point. So my dear student, let us see an alternative way of doing the same question. So here we just have an alternative, that is so alternatively, that is, we are going to apply the second derivative method. That is step 1. Of course, we differentiate our equation, that is dy dx, which is equal to 2x minus 4. So again, at the turning point, dy dx is equal to 0. So in this case, that is at the turning point, dy dx is equal to 0. So we have 2x minus 4 is equal to 0. So in this case, you have x is equal to 2. So again, we can find the value of y by substituting the value of x in our function. So in this case, only substituting the value of x in y is equal to x squared minus 4x plus 5, we have, so this time we have y, that is y is equal to 1. So in this case, we have the stationary point, that is the stationary point is 2, 1. So by using the second derivative method, we have to differentiate again, that to find the second derivative. So in this case, we are going to have d square y dx squared. This one will be equals to 2, that is 2. Now in this method, something which is very important, note in this method, if the second derivative, that is dy dx squared, is greater than 0, in this case we have a minimum point. So in this case we have a minimum point. And again, if the second derivative, that is d square y dx squared, is less than 0, so in this case we have a maximum, that is maximum point. But again, if the second derivative is equal to 0, then we have the point of inflection. So here again, that is again, if the second derivative is equal to 0, then we have what you call the inflection, that is inflection point. So in this point, if you can see, our second derivative is equal to 2, that is positive 2. So positive 2, that one is greater than 0. So in this case, we have the minimum point. So in this point, we say the stationary point, 2, 1 is a minimum, that is a minimum point, because simply because the second derivative, that one is greater than 0. So this one is the alternative way of finding the stationary point, but again to determine whether the point is a maximum or minimum. So dear student, we proceed with the second review question. So dear student, we have the second review question. This time the question says, find and classify the nature of all the critical points of the curve given by y is equal to 2x cubic plus 3x squared minus 12x plus 7. So dear student, we are going to follow the same procedure of finding the stationary point, but again to determine the nature of our stationary point, if it is a maximum or minimum point. So in this case, we are starting with the first derivative, that is, we differentiate our function. So here we have dy dx, which is equal to, this one will be 6x squared again plus 6x, then minus 12. So that is our first derivative. But you remember, at the turning point, dy dx is equal to 0. So here we say, but at the turning point, we say dy dx, this one is equal to 0. So we have 6x squared plus 6x minus 12 is equal to 0. So in this case, we can simplify our quadratic equation. That is, you can divide by 6, by 6, by 6, by 6, by 6. So we have, that is x squared, then plus x minus 2 is equal to 0. Now we are in the position to solve our quadratic equation. You can take your scientific calculator and just find the solution of this quadratic equation. So in this case, we have values of x are so, my dear student, we have the values of x, that is x is equal to 1 or x is equal to negative 2. So in this case, we are going to have two stationary points. So that is, let us find the values of y that corresponding to values of x. So that is when x is equal to 1. So we substitute 1 in our equation. So y will be equals to 2. Then we have 1 cubic, then plus 3, then 1 squared, minus 12 times 1, then plus 7. Y is equal to 2 plus 3 minus 12 plus 7, which actually is equal to 0. So we have the first stationary point, that is x, comma y. This one will be 1, comma 0. So again, let us find the second stationary point by using x is equal to negative 2. So again, we substitute in our equation. So in this case, that is when x is equal to negative 2. We are going to have y is equal to 2 negative 2 cubic, then plus 3, we have negative 2 squared, minus 12 times the negative 2, then plus 7. So in this case, we have y is equal to positive 27. So in this case, we have the second stationary point. That is the second stationary point, x comma y. This one is equal to negative 2, comma 27. So, my dear student, we're in the position to test our stationary point. We have two stationary points. The first one is 1, comma 0, but again the second one is negative 2, comma 27. Let us test this stationary point to see if they are maximum or minimum. So of course here we are going to create a simple table for the two stationary points. So where is our starting point? We can start with the first stationary point, that is when x is 1. So this time when x is 1, of course we are going to substitute the values which is in left hand side and the value in the right hand side, then to see what sign are we going to get. Now suppose we substitute 0, because 0 will be in the left hand side. So on substituting 0, that will be, so we have, that is, will be 0 plus 0 minus 12. So we are going to get a negative. That will be a negative. That is a negative 12. So that is on substituting 0, which is in the left-hand side of positive 1. But again, suppose we substitute 2. That is in the right-hand side of 1. So this time we are going to have, that is, we have dy dx will be equals to 6, then 2 squared, then plus 6, 2, then minus 12. So this one will be, that is 4, 24 plus 12 minus 12. In this case, we have 24. So 24, that one is positive. So at the right, we have a positive. So on rough sketching of this, it means we have a negative, the graph will go down. That is for negative. But for, of course, here we have 0, so that is the turning point. So for the case of positive, it means your graph will go up. So here the graph will go up this way. That is for positive. So again, what does that mean? It implies that here we have a minimum point. For the nature of our parabola, we have the minimum point. So in this case, our turning point, that is 1, 0, that will be a minimum point. So again, my dear student, we proceed with testing the second stationary point. So again, by using a simple table, that is value of x, that is sine of dy dx. So again, you consider two sides, that is left-hand side of negative 2 and the right-hand side of negative 2. Now this time suppose in our left-hand side we take negative 3. So in this case, we are going to substitute negative 3 in our first derivative. So we are going to have, that is when x is equal to negative 3, we are going to have dy dx is equal to 6. We have negative 3 squared, then plus 6, that is times negative 3, then minus 12. So in this case, we have this one is equal to, that is 9 times 6. So here we have 54, then minus, this one is 18, then minus 12. So the answer will be equals to positive 24. So 24 is positive. So the sign of dy dx, so this one will be positive because 24 it is a positive. Now what about a value in the right hand side of negative 2? So for the case of right hand side, suppose we take negative 1. That is negative 1 because the negative 1 is in the right hand side of negative 2. So in this case, we have dy dx is equal to, we have 6, then negative 1 squared, then plus 6 again, negative 1, then minus 12. So in this case, we have 6 minus 6 minus 12. So here we have negative 12. So you can see the value which is in right hand side of a negative 2, we have a negative. So here this one is a negative. Okay. So my dear student, what does this mean? It means if we make a rough sketching of the graph will go this way. That is for positive, the graph is going up. But when it reaches at the turning point, that is at 0, so the graph will tend to go down because there is a negative there. So it will be like this. So that is a parabola. And the nature of our parabola, we are going to have a maximum value somewhere here. So in this case, this stationary point is a maximum stationary point. So here we make a conclusion by saying the point negative 2, 27 is a maximum stationary point. So my dear student, you've seen how to differentiate the stationary point which is a minimum, but again a stationary point which is a maximum. So let us see the alternative way of doing the same question. So here just have an alternative. Remember, we are starting with the first derivative, that is dy dx, which is equal to 6x squared, then plus 6x minus 12. And again, remember, at the turning point, dy dx is equal to 0. So in this case, we say 6x squared, then plus 6x minus 12 is equal to 0. That means on simplifying our quadratic equation, we are going to divide by 6 in each term. So on divide by 6, we are going to have, that is x squared, then plus x or minus 2, this one is equal to 0. Now we solve our quadratic equation. So remember, xc is equal to 1, or xc is equal to negative 2. So these are the values of xc. So on the other hand, we can find the values of y, but again by substituting in our function. So on substituting values of xc in the equation, y is equal to 2x cubic plus 3x squared minus 12x plus 7, we have, so you remember, we are going to have the following stationary point. 1, we are going to have, the first one is 1, 0, and the second one is negative 2, 27. So those are our stationary point. So by using the second derivative, we can test our stationary point. So you remember, we are going to find the second derivative of what we are having here, that is dy dx is equal to 6x squared plus 6x minus 12. So the second derivative, that is d square y dx squared, will be equals to, this time we have 12x then plus 6. So that is our second derivative. So let us test. That is when xc is equal to 1. So we have d square y dx squared will be equals to, that means we substitute the value of x in our second derivative. So it will be 12 plus 6. We are going to have positive 18. So you remember, when the second derivative is greater than 0, then we have a minimum point. So in this case, since the second derivative is greater than 0, when xc is equal to 1, then the stationary point, then the stationary point 1, 0 is a minimum, point, as you have seen for the first method. So again, we proceed with the second value of x. So again, when xc is equal to -2, we substitute the value of x in our second derivative. So the second derivative will be equals to, so we have 12 times -2, then plus 6. This is -24 plus 6. So of course we are going to have a negative, that is a -18. So remember, when the second derivative is less than 0, then we have the maximum turning point. So in this case, we say since the second derivative is less than 0, when xc is equal to -2, then we say the stationary point, that is -2,27 is a maximum, point. So my dear student, you can make a comparison between the first method, that's by using the first derivative method, and the second alternative, that is by using the second derivative, to see which one will be suitable for you. Just a matter of choosing the method which is suitable for you. So my dear student, we proceed with the last review question. And the question says, find the turning point of the curve of the function f of x is equal to x cubic minus 1. So remember, we follow the same procedure. Let us start with the first method, that is we can say let f of x is equal to y. That means y is equal to x cubic minus 1. We are going to find the first derivative, that is dy dx is equal to 3x squared. But remember, at the turning point, dy dx is equal to 0. So here we say at the turning point, we say dy dx is equal to 0. So in this case, we say 3x squared is equal to 0. So we are in a position to solve for x. So of course in this case, dividing by 3, we are going to have, that is x squared is equal to 0. So solving for x, we have x is equal to 0. So in this case, we can substitute the value of x in our function to get the value of y. So in this case, we know that y is equal to x cubic minus 1. So y will be equals to 0 cubic minus 1. Therefore, y is equal to negative 1. So we have the stationary point. So in this case, we say the stationary point is, we have 0, comma, negative 1. So we are going to test to see whether this stationary point is a maximum or minimum or point of inflection. So we have to create a simple table as follows. So here we are going to have the value of x. Of course, here the sign of dy dx. So the value of x, this one is 0. So in the left-hand side of 0, we have negative 1. That is, of course, that is in the left and the right. So for the case of left-hand side, suppose we take negative 1. So we substitute negative 1 in dy dx. So negative 1 squared is 1 times 3. We have 3. So 3, this one is a positive. So here we are going to have a positive value. That is the sign of dy dx. So in the right-hand side of 0, we have 1. Now suppose substitute again 1 here. That is 1 squared times 3. So again we have a positive. So again we have a positive. So in this case, we say we have a point of inflection because the sign in the left-hand side is the same as the sign in the right-hand side. When the case like this, we say we have the point of inflection. So our stationary point, that is, since the first derivative, that is dy dx, is greater than 0 on both sides of the value of x, the value of x, then the stationary point which is 0, negative 1, we say is the point of inflection. That is inflection. Even if the sign in the left-hand side was negative and in the right-hand side was negative, also we say we have the point of inflection. So, my dear student, you've seen how to find the stationary point for the given function, but again to determine its nature, if it is a maximum point or minimum point or the point of inflection. Now it is time for assignment. So, dear student, this is the assignment for you. There are 2 questions. The first question is to find and classify the nature of all the critical points of the curve given by y is equal to x cubic plus 3x squared minus 9x. But again, the second assignment question, that is find and hence state the nature of the stationary point of the curve y is equal to x cubic minus 3x squared minus 9x plus 2. I'm sure you'll manage to do the assignment questions because you know the procedures of how to determine the stationary point, but again, to find its nature, if it is a maximum point or a minimum point of the point of inflection. It is my hope that you enjoyed this lesson. Don't miss another lesson of advanced mathematics. Till next time, have a good time. Bye.